Okay, so again, this one multiplies the top to become the new numerator. The denominator is the same. And then the other one, it's fairly straightforward. We just have a 2 on the top and a 3x minus 1 on the bottom. Now, just to get you thinking about where we're going with this for later, you should see that you can make a common denominator here of 3x minus 1 squared. So if we were to just take a 3x minus 1 over here, then we could make this 3x minus 1 squared. And now they have a common denominator and we can join them together, right? So we could take this positive term here and actually bring it over here. And then we could just dispense with this second one altogether. And you can actually get this down to something fairly simple, right? We could just copy it here and finish cleaning it up. So we have 2x, 2 times 3x is 6x. Then we have minus 3 times 2x is also 6x, so that's going to disappear. We have negative 2, take away 15, so we just get negative 17 on the top, right? So it actually simplifies down to something fairly straightforward, and again, GeoGebra should be able to confirm what I did there is right, provided I didn't make any mistakes. So let's go 2x plus 5 divided by 3x minus 1, and then let's go derivative f. And you can see it comes up with negative, and we'll just factor f prime, and you can see it comes up with what I said, right? Negative 17 on the top and 3x minus 1 squared on the bottom. Something like this I would expect you to be able to simplify, because something like this, later in the course I might ask you to solve. So again, for what this question says, it says find the slope of the tangent. You don't need to go through this step. As soon as you get to here and you have a derivative, you could just sub in 0 into your derivative right there and you'd be fine. But you should push yourself to practice simplifying these ones, just because you will be asked to do that sooner or later, and you might as well get the practice in now. Anyway, when we want to, and also, to sub in 0 into my equation is actually pretty easy, right? Because it's negative 17 over 0 minus 1 squared, and I can get f prime of 0 is equal to negative 17 really easily. You would get the same number if you plugged it into here, but of course it would be, tricky, a little trickier to get that actual value. Anyway, you'd still get the same number. Again, I'll double check here. We get f prime of 0 and it gives us negative 17, which is what we expect. So we only needed the slope of the tangent, so that's what that would be. The slope of the tangent would be negative 17. Okay, now the last thing to do today is just an example of an application question. It says a tank holds 500 liters of liquid. It takes 90 minutes to drain from a hole at the bottom of the tank. The volume remaining in the tank after t minutes is given by this quadratic. How fast is the liquid draining at 30 minutes? What is this question asking? It's asking what is v prime of 30, right? Because v prime would be how quickly the tank is changing volume. And of course, to change volume is to be draining in this case, since it's going to be negative. So how fast is the liquid draining? That's asking you what is v prime of 30. That's literally what that means, right? So if you look at this one, let's just take a quick look at this one. So we get 500, 1 minus t over 90 squared. 500, 1 minus x over 90 squared is our equation. And of course, it should have a y-intercept at 500, which it does, and then it should have an x-intercept at 90, because that's when the tank is fully drained. You can also see that the tank drains more quickly at the beginning, and it drains slower and slower and slower as it sort of as there's less and less water in there. I guess you could imagine that's because there's less pressure kind of pushing it down as there's less, as the tank is less full. In any case, to solve something like this, all we need to do is find its derivative and plug in 30. So let's try and find its derivative. Now, this is not an example of a product rule, okay? Because, some people are going to look at this and they're going to go v of t equals 500 times 1 minus t over 90 squared, and they're going to think that 500 is a function and 1 minus t over 90 squared is a function. You can do that. It is right. It would work. But the derivative of 500 is 0, so the second chunk you would be creating doesn't do anything. So it's easier to just think of this 500 as a constant that's multiplying your equation. So v prime of t, okay, is going to be the constant 500 and then times the derivative. What's the derivative? Bring the 2 in front, write 1 minus t over 90 to the power of 1, and then take the derivative of inside the bracket. What's the derivative of the bracket? The derivative of 1 is 0. The derivative of negative t over 90 is negative 1 over 90. Right? And if you're not convinced of that, then just write it a bit differently to help yourself. Remember that t over 90 can also be written as 1 over 90 times t, right? And then you can kind of just easily see that, yeah, okay, the derivative here would be I drop the t and I keep the coefficient, right? Since it's negative, my derivative is negative. So that's it, right? If I'm looking here, this is the equation, that's the derivative. Let's take a second to make it a little bit more friendly, but you don't really need to do this. You could just sub it in now. So we get negative 1,000 over 90 times 1 minus t over 90, right? And even this can be cleaned up a little bit. We could change 1,000 over 90 to 100 over 9. And now we have an equation where we just need to plug in 30, which would give us negative 100 over 9 times 1 minus 30 over 90. 30 over 90, okay, so v prime of 30 is equal to negative 100 over 9 times, let's see, 90 over 90 minus 30 over 90 is 60 over 90, and then we're just simplifying this. So let's simplify this 60 over 90 down to 2 over 3, and we get v prime 30 equals negative 200 over 27. And of course, it's a rate of change question. So a rate of change question requires that you write the unit. The unit is whatever y is measured in divided by whatever x is measured in. Okay? So I'm going to write y units over x units. Now, what does that mean in this case? The tank is draining at a rate of negative 200 over 27 liters per minute, right? Y unit is liters, X unit is minutes, when t equals 30 minutes, okay? And that's how you give the answer here. You got to tell me the rate of change unit if you want full points on any application question, because part of understanding what you're doing is telling me the unit that is being measured in. Okay, let's check my work on this one. Let's do derivative of f. Let's do f prime of 30. We get that negative 200 over 27, you see, which is just the answer that we're looking for. Again, to draw the tangent here, so let's go 30 and f of 30, and then we'll go tangent AF, and it has a slope of negative 7.4141, but that is actually that is 27 over 200 over 27, right? If you just make this a decimal, that slope is right there. Okay, so go back to mx plus b form, and it has a slope of negative 200 over 27. Okay, so for today you've got some homework you can try. I think there's another assignment. There are already 2 assignments out already, so lots of stuff to do. Use your time well. If you have questions, you can pose them to the website. You can also share them with me tomorrow. We can go over it. But this should give you a pretty good primer on how to deal with the product rule. We'll go over any other, any issues or problems tomorrow, and be ready tomorrow to take on the quotient rule.